Hello, we are from Group 9. So in this video, we are going to explain about paging concept and how it's applied in the real application. So, what is paging and how does it work? Paging is a memory management technique in operating systems that enables processors to access more memory than is physically available. They do this by retrieves data from a device secondary storage to the primary storage. A primary storage is usually kept in random access memory for quick retrieval, and an SDD is the example of secondary storage. The primary memory is divided into little pieces of physical memory known as frames. Okay, so here's the analogy of it. Imagine that there is a library that organized by an efficient system, much like how operating system manage the memory. The library had rows upon rows of shelves, each filled with countless books. The library used a special method to find a book easier by dividing the entire collection into smaller, fixed-size sections called book pages. Each book page could hold a certain number of books. When a visitor entered the library looking for a specific book, they didn't need to wander aimlessly. Instead, they would go to the information desk, where the librarian acts like the operating system. The visitor will give the librarian the title or topic of the book they were looking for. For example, if the visitor wanted a book on ancient history, the librarian would consult the master index, which is similar to a page table in an operating system. The librarian would direct the visitor to the specific book page where the ancient history books were located. This saves visitors a lot of time as they only need to look through a few book pages. In the same way an operating system manages memory using paging, the computer's memory is divided into small, fixed-size blocks called pages. When a program needs to access data, the operating system uses a page table to keep track of where each piece of data is stored in a memory. Instead of searching through the entire memory, the operating system quickly finds the needed pages and retrieves the data from the physical memory, making the process efficient. One day, a visitor wanted a very popular book that was currently being used by another visitor. Just like in virtual memory, where not all pages need to be in physical memory at the same time, the librarian kept a list of borrowed books and their expected return times. When the book was returned, the librarian would notify the waiting visitor just as the operating system swiped pages in and out of physical memory as needed. Let's say the program requests for e-data which is in page 1, but there is no page 1 in physical memory. As you can see, the operating system swept in the page that the program needed. So how this paging concept apply in real-life application? My friend here will show you a demo for the system we choose. So let's begin.
Good morning, Dr. Zafran. I'm Wei from Group 9, and today I'm going to demonstrate how the library system works based on the paging concept. So now I'm going to look for a book. So there's a place for us to search for the book. So I'm going to search for a book named Moby Dick. And once I click at the Go button, the system will request for the book. So now the system returns four results, and for the similar book that I searched for. So now I'm going to click at this option, and once I click at the option, what happens is the system will request a specific memory page for the system for the book. Okay, so as doctor can see, the system now direct me to the page that shows the details of the book that I just clicked. So the operating system of the book of the library system actually translate the logical address to physical address, and then it display this page by retrieving the specific memory content that memory content of the book.
So that's the end of it. Bye bye.